Okay, now question number 21. In question number 21, we have to prove cos 4x plus cos 3x plus cos 2x by sin 4x plus sin 3x plus sin 2x is equal to cot 3x. I am taking the LHS part here. And on the RHS it is 3x, hence I am taking the LHS, and I want to separate the 3x part. That means I am writing it like this: cos 4x plus cos 2x plus cos 3x by sin 4x plus sin 2x plus sin 3x. This can be written as formula. Applying the formula cos a plus cos b, I get 2 cos a plus b by 2 and cos a minus b by 2. Here a is 4x, so I am putting the values 4x plus 2x by 2, and here it is 4x minus 2x by 2. In the end, I have to write plus cos 3x. Similarly, in the denominator it is 2 sin a plus b by 2 and cos a minus b by 2. Putting values again, it will become 4x plus 2x by 2 and 4x minus 2x by 2, then plus cos, sorry, it is sin 3x. Okay, now I am solving it and it comes out as 2 cos 4x plus 2x is 6x by 2, that means cos 3x multiplied by cos x plus cos 3x. In the denominator it is sin 3x into cos x and plus sin 3x. Okay, now I am taking common. I want to take common. Now I can take common, it is 3x, actually it is 3c written, it is 3x, it is 3x. Now I want to take common. From the numerator part, I know I can take common as cos 3x. So cos 3x is common, so it is cos 3x. What remains? It remains 2 cos x plus 1. And the denominator part, I can take common as sin 3x. Sin 3x, what remains common is 2 cos x, 2 cos x plus 1. 2 cos x plus 1 in the denominator and 2 cos x plus 1 in the numerator cancelled out. So it remains cos 3x by sin 3x, which is nothing but cot 3x, and this is our RHS part, hence proved. Question number 21 has been proved. Now we go to question number 22. Now we go to question number 22 on the next page. The question says we have to prove cot x multiplied by cot 2x minus cot 2x multiplied by cot 3x minus cot 3x multiplied by cot x is equal to 1. We have to prove it as 1. Okay. In this question, it is actually a formula of cot A plus cot B put in a different manner. Now we have to apply the formula. We know that there is a formula of tan A plus B. Similarly, there is a formula of cot A plus B. I can apply the formula. Now I am applying the formula and I am writing it as cot 3x is equal to cot 3x. That implies this cot 3x is cot 3. That implies this. I am taking it. 1 second. That implies this cot 3x is equal to cot. Now I am writing 2x plus x in place of 3x. Okay. Okay. It becomes cot 3x is equal to. Now I am applying the formula cot A plus B. I know that cot A plus B is equal to formula cot A cot B minus 1 upon cot A plus cot B. This is the formula. I am applying the formula here. So cot 2x plus cot x is equal to cot 2x into cot x minus 1 by cot 2x plus cot x. Now cross multiplying, I will get cot 3x will multiplied by cot 2x and cot x. It becomes cot 3x multiplied by cot 2x plus cot 3x multiplied by cot x is equal to cot 2x multiplied by cot x minus 1. Okay. Now look at the requirement. Always look at the requirement. The requirement is we need 1 as positive, so I am taking 1 on the other side to make it positive. Okay, so it becomes, that implies is 1 is equal to cot 2x cot x, and shifting this cot 3x to x minus cot 3x cot 2x and minus cot 3x cot x. Actually this is our requirement and we have fulfilled our requirement. A cot x cot 2x. This is proved. This is our requirement and it's proved. Now we go to question number 23. In question number 23, it is the formula of tan 4x. It is the formula of tan 4x. 1 second. I am making space here. This formula of tan 4x. Tan 4x is equal to, we have to prove it as 4 tan x 1 minus tan square x by 1 minus 6 tan square x plus 10 to the power 4x. Okay, I am taking the LHS part and applying formula. LHS is equal to tan 4x. Now tan 4x can be written as tan 2x plus 2x. We know the formula of, there is a formula of tan 2x. Tan 2x is equal to 2 tan x by 1 minus 10 square x. So I am applying the formula and it becomes 210 2x by 1 minus 10 square 2x. I am writing the formula here, as the formula is 10 2x is equal to 2 10x by 1 minus 10 square x. This is the formula. I am applying the formula in this. Okay, now from that I get, and again applying the formula of 10 2x on the denominator and numerator, it becomes 2 times. Now 10 2x is again 2 10x by 1 minus 10 square x. Similarly on the denominator side it is 1 minus, now applying the formula here, 2 10x by 1 minus 10 square x and its whole square, because it is written as 10 square 2x. So 10 2x is 2 10x by 1 minus 10 square x and its whole square is equal to, now the numerator becomes 2 to the 4, so it becomes 4 10x by 1 minus 10 square x, and for the denominator I have to first making it a whole square, so it becomes 2 10, it becomes 4 10 square x. Now 1 minus 10 square x whole square, so it will become 1 minus 10 square x and its whole square. Okay, now again I will want to solving it. Okay, the numerator remains same, 4 10x by 1 minus 10 square x, and the denominator I am taking LCM. The LCM is same as 1 minus 10 square x, so it is 10 square x, I have written it 10 square x and its whole square. This is LCM. Okay, so it becomes 1 minus 10 square x and its whole square minus 4 10 square x. Okay, that is equal to, now I can make it as 4 10x by 1 minus 10 square x multiplied by, this can be reversed, hence I am writing it as 1 minus 10 square x whole square by, now I am applying formula MNSB whole square, it is 1 plus 10 to the power 4 x and plus, actually here is a 4, I have mistaken it, it's 4, 10 square x 10 to the power 4x plus, and 1 second, a square plus b square minus 2b, minus 2 10 square x, now minus 4 10 square x. I'm writing it, 1 second. Now if I look at the numerator and denominator, It is actually 1 plus 10 square x whole square and 1 minus 10 square x whole square in the numerator and 1 minus 10 square x in the denominator. 1 minus 10 square x is cancelled out, so it remains 4 10x multiplied by 1 minus 10 square x, and in the denominator I got 1 plus 10 to the power 4x minus 6 10 square x, and it is our requirement is fulfilled. This is our RHS actually, 4 10x 1 minus 10 square x 1 plus 10 to the power 4, and this is our RHS. Actually this is our RHS part is equal to RHS and proved. Now we go to question number 24. Question number 24. Question number 24 is formula of cos 4x. Okay, it is cos 4x. Similarly, and it is written as 1 minus 8 sin square x multiplied by cos square x. I have to prove this cos square x. In this formula again I am taking the LHS part and writing cos 2x, cos 4x, and putting the formula. Hence it is LHS is equal to cos 4x, that is equal to cos 2 into 2x. Now I am applying the formula of cos 2x. Now in the RHS part I need 1 minus something. The cos 2x has many formulas. 2 sin square x, 1 minus 2 sin square x, 2 cos square x minus 1 cos square x minus sin square x. So 1 minus 2 sin square x type formula. So 1 minus 2 sin square, sin square x, in place of x I have to write 2x because x is 2x here. Okay, formula becomes 1 minus 2. Now sin square 2x, sin square 2x can be written as, there is a formula of sin 2x. Sin 2x formula is 2 sin x cos x and its square, so it becomes 1 minus 2 multiplied by 2 square 4, and it is sin square x multiplied by cos square x. That becomes 1 minus 2 and 4 8 sin square x multiplied by cos square x, and this is actually our RHS. Simple question and very simple answer proved. Okay, now I go to the last question of the exercise. The last question is question number 25. This is cos 6x is equal to 32 cos to the power 6 x minus 48 cos to the power 4 x plus 18 cos square x and minus 1. This is the result. I have to prove. I am taking the LHS again. LHS is equal to cos 3x, sorry 6x, it is 6x. I am applying the formula, so I can go two ways. I can apply cos 2 into 3x, or I can go for cos 3 into 2x. There are two ways to solve this question. I will go for cos 2 into 3x. So I am making a bracket here, 2 into 3x. I am applying the formula cos 2x. In the cos 2x formula, I need a minus 1 at the last. So I will apply formula of, it is 2 cos square x minus 1, but my x is 3x, so I have to write 2 cos square 3x minus 1. Okay, now 2 cos square 3x, 2 cos 3x, I have to apply formula cos 3x. I know cos 3x formula, it is 4 cos qx, 4 cos qx x minus 3 cos x. Now it's whole square. So 2 and cos qx, sorry, cos square 3x, cos 3x formula for cos qx minus 3 cos x, its whole square and minus 1. Okay, now it is 2 on the outside, and it is, I am putting off it, 2, I'm taking this in bracket here. Now 4 a minus b whole square, that means 16 cos to the power 6 x plus 3 square 9 and cos square x. Now minus 2 ab, so 2 4s are 8, 8 3s are 24 cos cube and cos x, 24 cos to the power 4 x, bracket completed, minus 1. I have just put a minus b whole square formula here. Okay, now one second, now is equal to, I am opening the bracket, so 2 into 16, that becomes 32 cos to the power 6x minus 24 into 2, 48 cos to the power 4x, and now 9 2 is 18, 18 cos square x and minus 1. And this is our requirement, 32, this is our RHS, this is equal to RHS, and hence proved. Very easy question, and by this I have completed exercise 3.3. Next we will do exercise 3.4. okay, if anyone have any query, you can contact me for theory related or query.